Welcome. This video discusses exploratory data analysis for case CC, two categorical variables. Specifically, here we will be creating two-way tables, also called contingency tables, which provide a breakdown of the number of observations in each combination of the levels of the two categorical variables. Percentages can also be calculated by the software. Later we will look at the inferential components formally, but we will point out some of the options which will be needed as we see them in the options during this tutorial. In order to follow along, you will need the SPSS dataset pulse_step3.sav after translating the original coded categorical variables, which we already have opened. To begin, we go to Analyze Descriptive Statistics, Crosstabs. We need to specify which variable or variables we want in the rows and which in the columns. If you place multiple variables in both boxes, you will get all possible combinations between the two sets of variables, row and column variables. To begin, we will look at the treatment variable, whether the student ran or sat, as the single row variable, and pair it with all of the other categorical variables in this version of the dataset: gender, regular smoker, regular drinker, frequency of exercise, and we will include year as well. Let's look at the default results and simply click OK. At the top we get the case processing summary, which, as we've seen before, isn't too interesting for our nice data set with no missing observations. If we had missing observations, we would need to look at the summary to determine how many and for which variables. Then we get each two-way table with the treatment variable, whether the student ran or sat, in the rows. Labeled with ran or sat because we set up the data to have values for each of the coded categorical variables. If we had not, we would see the codes here. Looking back at the data, we see that for the treatment variable, the codes are 1 and 2. In the variable view, we can see the codes if we need to remember by looking back at the values. The tables do give us the totals for each row, column, and overall, which is nice. If we simply ask for the two-way tables, these will be fine. However, as we learned in the materials, in a particular scenario, we are usually interested in a certain set of conditional percentages. We can have the software calculate these for us automatically in the options. So let's go back in and look at the options that are available for two-way tables. Go to Analyze Descriptive Statistics, Crosstabs. Let's reset the tool and choose only a few tables to keep the output reasonable. It is nice to be able to analyze a lot of data simultaneously, but this can also produce too much output at one time for comfort. Let's look at the treatment variable as the row variable and use gender and exercise as the column variables. The exact option allows you to run Fisher's exact test, which we will discuss later in the semester. Some of you may not have the exact option, which is okay. You will not be required to run this analysis yourself. The statistics option will be where we will go to choose the chi-squared test. There are also a number of other measures of association which can be calculated using this menu, but we won't cover them in this course. The cells option is what we want now. To calculate conditional percentages, we can choose either the row percentages or the column percentages, or both if it isn't too confusing to see everything at once. We will look at this one at a time. We choose row percentages now. Before continuing, notice that you can also calculate what is called the total percentage. This is the percentage out of the overall total in each of the cells. This is not usually of interest, as we want to compare the distribution of one variable within the levels of the other variable. We don't need to know what percent fall into each cell overall. At the top, we have the expected count, which will be of interest when we cover the chi-squared test. Click Continue after selecting the row percentages. We don't need the Format, Style, or Bootstrap options. There are two other options to notice in the checkboxes at the bottom. We can display clustered bar charts and suppress the tables. Here we definitely want to see the tables, but let's ask for the bar charts to see the results. Again, we get the case processing summary. Then we get the two-way table for the first pair, treatment by gender. The percentages are labeled as percent within whether the student ran or sat. The first row gives the percentages of males and females within those who ran. And the second row gives the percentage of males and females within those who sat. We can see that it is relatively similar, with slightly more females in the ran group than in the sat group, or slightly less males in the ran group than the sat group. Then we get the bar charts. Nice, but since they give the counts, they can make it difficult to compare the distributions accurately if the sample sizes are not close in the groups being compared, ran and sat in this case. If you use the graph builder, you can choose the appropriate denominator for a given situation, the total, row, or column. We don't focus on these graphs, but on being able to understand the two-way tables directly. Okay, let's look at the last options. Go to Analyze Descriptive Statistics across tabs. Again, I'm going to reset the tool. We will still use treatment as the row variable. We will look at year as the column variable. Go to Cells and choose Column and Total from the Percentages area. Click Continue and OK. Again, at the top, we have the Case Processing Summary. For the two-way table, we have the count in each cell, the percent within year of class for each cell, and the percent of total for each cell. I chose column percentage for this combination because in the experiment during the first year, students flipped a coin to determine if they ran or sat, and maybe they didn't all do what their coin said. Is there evidence that less than 50% of students ran in that year? In our table, only 30.8% ran in 1993. However, we also see in 95 it was 40.9%, and in 98 it was 37.5%. Later we will learn to calculate how likely it is that these values could be due to random chance. In other words, what is the chance that out of the 26 students in 1993, only 8 of them flipped heads on their coin? There is some evidence that less than 50% of students ran in 1993, but only circumstantial at this point. The percentage within total is not usually interesting in a practical setting, as these do not allow us to make easy comparisons between the levels of the row variables or column variables, depending on what makes sense in a given problem. Learning to read the output in these tables is an important learning objective, so please let us know if you have questions. We will save this output as topic6a.spv. That's all for now. Thanks for watching.